Put walls have become popular in the past several years as a means of fulfilling large numbers of orders from a large picking area. Single order picking is infeasible if the entire picking area must be traversed for each order. Batch picking with many orders, for example 10, on a cart is an improvement, since one trip through the large picking area can fill multiple orders. Batch picking large numbers of orders, for example 200, may still be too inefficient since 20 trips through the large picking area would be required. Wouldn't it be nice to fill 200 orders with a single trip through the large picking area? Unfortunately, we may not be able to build a cart large enough to hold 200 orders. This problem is the motivation for classical put walls. This diagram shows a picking area with, for the sake of simplicity, only 3 aisles, but would in practice be a very large area containing many aisles. The picking area is divided into 3 partitions, and a cart is dispatched to each partition to pick products in bulk for a large number of orders. When we say in bulk, we mean that when a SKU location is reached, the number of units of the SKU required for all 200 orders is picked and placed into a tote on the bulk cart. This simple diagram shows red and green totes since the bulk carts are picking for a red put wall and a green put wall. The colors are only used to aid in understanding the diagrams. After picking in each partition of the large picking area is completed, the carts are unloaded at 2 put walls. In our example, each put wall contains 100 slots or cubby holes into which products are placed or put to build orders, 1 per slot. 1 or more putters scan products on one side of each put wall, and 1 or more packers remove products from the other side when a slot contains all required items for an order. Light modules are used on slots on the put side of the wall to indicate where and how many of each product should be put. Light modules are used on slots on the pack side of the wall to indicate which orders are completed and which size cartons should be used for packing. Put walls reduce the number of trips through the large picking area, reduce the walking distance to put items into put wall slots, as the distance to walk to or place items into put wall slots is only a few steps. Coordinate putting and packing, since the put wall slots are open on both ends to enable putting in one end and packing on the other end. Enable order consolidation from multiple picking zones by scanning order items picked in multiple zones are placed into the same put wall order slots. Enable sorting of products for reverse logistics by assigning each put wall slot to a section of contiguous bays in a put away area. Unfortunately, there are drawbacks to put walls since products must be touched 3 times. Once when picking, once when scanning and putting, and once when removing products from the put wall slot for packing. FastFetch has developed a system that retains the advantages of put walls while reducing the number of touches by more than half. We call this system dynamic put walls. In this simple example, you see a diagram with 4 carts, each containing a tablet and each loaded with order shipping containers, perhaps corrugated cartons, ready for picking. These carts contain light modules adjacent to the containers to indicate where and how many of each product should be placed during picking. Many distribution centers follow the 80-20 rule, in which 80% of the order items will be picked from 20% of the products. The 4 carts in this diagram are dispatched to a slotted, high-velocity area containing 20% of the products, and where 80% of the products required for these order containers will be picked. The picking bins in the slotted area also contain lights to indicate where and how many of each item in a bin is required. For example, a particular bin may be illuminated with the number 10, indicating 10 units of the product in the bin should be picked. Simultaneously, lights adjacent to 4 order containers on a cart may be illuminated with the numbers 4, 1, 3, and 2, indicating that 10 units should be placed into those containers in the quantities indicated. After traversing through the slotted area, one would expect about 80% of the products required for the orders on each cart would have been placed into the cart containers. Unfortunately, 20% of the required products remain unpicked. Concurrently with order cart picking, bulk carts are dispatched to different partitions in a large, low-velocity picking area containing about 80% of the products in the DC. Collectively, the bulk carts traverse the entire low-velocity area with a single pass through the area. In this example, each bulk cart contains 4 totes corresponding to the 4 order carts traversing the slotted area. The totes are shown in different colors to aid understanding. The bulk carts are then taken to an empty area of the distribution center, and each of their 4 totes are unloaded in a different designated location. In this example, all the totes of each color are unloaded in a designated area. The order carts are then moved to the designated area and positioned near their corresponding totes. Software on order cart tablets then dynamically, digitally transform the hardware on the order carts to function like put walls with light modules adjacent to order slots. The items from the totes are scanned, and lights on the put walls, formerly order carts, are illuminated, indicating where and how many of the scanned products should be placed in each order shipping container. When all items for an order have been placed in a slot, the word "Done" will be illuminated, indicating the shipping container can be removed and labeled with an LPN and sent to downstream processes. Put walls greatly reduce walking time, since the picking area is traversed only once. Additionally, the total number of touches is greatly reduced, since 80% of the products are picked from the slotted area and only touched once, while 20% of the products are touched twice, rather than 3 times. The total product touches are consequently reduced by more than 53%.